So today the session is about what is the purpose of a structural design and how we are going to use CAD softwares in structural design engineering and what is the purpose of analysis. So before moving into the tool-oriented demo session, we'll start up with what is structural engineering actually. So it is nothing but we are going to develop a skeleton for a particular building. Like for example, what is a structural engineer is? Once you are going to start up a site or any kind of project, we are going to start up with a building oriented designs. The first thing is we are going to develop a concept of this particular building. So it can be how we are going to develop that particular building, what is the purpose of it, and what type of building it is. So there are multiple case studies in it. Like it can be a hospital building, or it can be a traditional building, or a commercial, retail, or a residential one. It has multiple purpose for a particular building. Apart from it, the structural thing, what it plays is how it's going to sustain on this particular thing. What are the steps that is included in order to analyze a building? So what is the purpose of this software that you're going to use in a structural engineering format? So here, so it is once a structural engineer comes into this design technique, the basic function is it is about the calculations of load and calculations of analysis. So what is going to be the load that's going to be applied for each and every part of the structure and how it is going to manipulate with our real-time environment. And coming to the next thing, it is about an architect and an artist. So what he's going to do is he's going to just develop a concept with multiple visualization techniques. Like he might make his design more beautiful. Apart from it, once coming to the structural person, even though the building is going to be beautiful up there, we are going to place the entire skeleton of that particular building in order to make it a sustainable one, a stable one. And the next thing is what we are going to do here. So first, the thing is it is going to be a consultant format. Like you're going to take a design and we're going to develop some structural elements on it. Like it can be columns, footings, beams, as well as multiple things up here. And then once it is, there are several steps to analyze a building first physically. The first thing comes up with the soil test and other formalities. So once the soil is going to be fine for our concrete to set up with it, and we could develop the project much more easier for our structural design orientations. Like for example, the soil has generally the earth has several layers. Yes, I guess what I speak may be familiar with you people. 1 minute. So I guess what we see here is going to be familiar with some people up here. So the thing is, once you are going to develop a structural design, the first thing is soil test. Like after the soil test is fine, once your soil is fine with your model, then we'll go up with the structural orientations. So how you are going to shape your building in the form of footing, foundation, columns, and beams. So how we are going to integrate these things into a single discipline to form your entire concrete structure. So you have multiple softwares to develop structural engineering. Like for example, you might be well known of Revit actually, which plays a most viral part in BIM actually. Apart from it, for a specular analysis, we'll go up with StatPro, that is meant only for an analysis purpose. And then we have Tekla, which is specifically designed for steel designs and steel construction orientations. And in Autodesk, we have advanced steel. There are multiple softwares in this current industry. The factor is which software is going to be used is based upon the project and based upon the user's preference. So then the next thing is structure is nothing but it is, as I said earlier, it is about the skeleton of a building, and it's going to be in form of concrete mixtures with the beams and columns. So generally, these are building structures comes under residential. So the next thing is that's what a building design is. Structure is nothing but it's based on houses and retail building, commercial and all. Non-building structures comes under bridges, tunnels, and dams, and much more better things to work with. So the basic things what you're going to consider on analysis purpose is the forces. So how does a force define you? So there are two types of forces actually, which is applicable on all kind of physical activities. Like one is going to be a static one, the other is going to be a dynamic one. The static is nothing but it's going to be stable, it's going to be fixed on a single place, and it won't change at all. Whereas a dynamic force has a changing time, like it can be a people, furniture, as well as a disaster management, like it can be a wind force or earthquakes and multiple things. So all these things will be made on a pre-calculation to make our building more sustainable. That is called as a structural engineering. So we are going to make our structure more stronger, much reliable, and its lifespan is going to be increased based on the design that we are going to make it as an input. So then there are two types of forces acting on it. Like it can be an axial force and it can be a bending force. Like see, if you are having a column with an even length, the axial force will be on two opposite corners, as well as once you place a momential force, it is going to be on only one part of the column or beam. So this tensile force is nothing but it is based on your material property, and it is majorly used on water-based projects. Like you're going to put up a pile foundation or something inside a lake or something. It is based on the material to see about the compression force and the tensile force. So these are the factors that must be considered once you're going to develop a structural design. And then comes your strain forces. Stress is nothing but based on the load that's going to be act on that particular area. So these are the common terms for design orientations actually. Now I'll pitch up with the software so that you'll get a clear idea what is structure generally does with the software orientation on CAD. So this is Revit actually. It is 2021. So what I'm going to do is I'm going to open a sample structural project for you people. So the thing we've seen till now is just an orientation. So it is going to be like we are going to build a structure. We are going to calculate some of the basic formalities that's required. So generally what is being incorporated into the design is going to be the next one. Let us wait for the model to get open. Here in the structural tab, we'll be having an option like this. So the software is somewhat similar in all aspects. Like for example, if it is Tech Class, Stat Pro, everything, the detailing concept as well as the modeling is somewhat same in every software, in every three modeling software. The only difference is the names and the developers of that particular product. Now we'll move to this plan view actually. So generally in structural orientation, what are the basic components that is needed here is beam as well as floor, footings, foundations. So all kind of tools that is required for a structural design is being incorporated into Revit actually. Apart from it, we have a special option called in Revit, which is called as reinforcement and rebar detailing. It is available from the Revit's earlier version. Like for example, after 2013 of Revit, we have after 2015 of Revit, we have Revit into a single software. Before Revit was divided into multiple, like you have Revit architecture as separate, Revit structure as separate, and Revit MEP as separate. But after 2015, it has been collaborated into a single unit called as Revit, and we have structure systems, which is mean for MEP, and for architecture into a single discipline called as entirely Revit. The name Revit will define you as revise instantly. It means that you are going to make up your changes instantly for your model, whereas it will be updated on whatever the views you are going to generate on it. Let us create a 3D model here. Yeah. So I hope this model is useful for you people. So hope the model is visible for you. So it is just a simple steel structure here. Now the thing here is, here it is built with rebars inside. I hope you can see the bar bending inside. We're going to make it visible. We can make it visible. I'll just move somewhat fast with the command, so we don't have enough time up here to elaborate those things. So now I hope you'll be able to see the rebars up here for this particular model. See, so these rebars are created in Revit itself. So we have specific family for rebars actually. So in Revit, it's based on family basis. Once you select a particular rebar, and you can see what type of rebar it is, how you are going to develop it, what is the bar diameter. So everything is predefined in Revit actually. And if you're going to make your own customization for Revit, you can do those kind of things also. You can create some parameters to find weightage as well as load orientations for your model, and we have multiple aspects for it. And then you have here you have a structural option here again. So apart from reinforcement, the other interesting topic what we have, the latest thing is about steel. So steel connections, it is like if you are going to create a truss building or any kind of steel structures, we have maximum of all the options up here. And some are based on families up here. So I'll show you some family files that will incorporate you for structure orientations here. And here you can go into the structural element. So you have structural connections, structural columns, structural foundations, framing, precast, rebar shapes, rebar couplers, and we have much more here. So what I'll do, I'll move into this structural truss. See, you have multiple orientation of truss families, which is used to create steel designs. Apart from it, you have steel columns also, which is also called as structural columns here. And you have a concrete, light gauge steel and all. So what type of concrete is that? You have a C type, double channel, H bearing or I beams and all will be having. So now you might have a question that what are the standards that has been followed in Revit? It is an US or an Indian standard of structural codes and all. So in order, I think you may have these kind of orientations on StatPro. So StatPro has a default Indian structural codes and all. So why does Revit doesn't have? The thing here is once you're going to work with Revit, we are going to customize the entire thing using Revit technology. Like template for us. So we're going to work on the template to create our own customized shapes and columns to form up a library in Revit. That is the only thing you're going to work on. We are going to do a pre-work in Revit in order to create your structural elements based on your codes. It has American standards and all, something will be available here. In order to make your own library, you must go into the entire progress to develop our own families on Revit structure. And someone has a question that is it helpful for is my screen visible, ma'am?
Yes, it is visible, Mr. Damodaran.
Okay. Someone has asked me a question that is it useful for a mechanical engineer like Revit or something? The thing is, once you are going to a mechanical discipline, we have a tool in Revit called as MEP, which comes for mechanical, electrical, and piping. See, the thing is, it is not like the Department of Engineering once you're learning a software. So if you are learning a particular tool for you, engineering is actually collaborated. Sorry. If you are going to work on a building project or anything, we have all kinds of activities involved. Like let us take an industry as an example. If you're going to design an industrial project, I need a mechanical engineer to develop my machineries as well as everything and all. And also I need a structural person to develop my structure for my entire industry. And also I want electrical engineer to choose my electrical systems for my entire industry to run up with. So it is collaborated. So BIM is a collaboration actually. So we have all kind of engineers involved into a single software actually, single design process. So it is not like mechanical or something related to it. Even a mechanical engineer must know the standards of civil industry, and civil people must know the basics of those things also to integrate your design creativity much more better. And then coming into this steel designs again. So once you're going to create any kind of steel drawings, Revit plays a vital role in creating those things also. Like see here, you can create pile designs actually. So it is like a footing up here. So the basic advantage in Revit is we can develop each and every structures on an independent view. Like this is going to be the model, but the same model I can develop into multiple segments like this. So one model I can develop into multiple views to show to my client or a customer regarding the progress actually. And coming to the analytical model, you can show what type of load that is being placed up here. See, let me show you a detailed thing for this. Let us go to this analyze tab. So here you have load combinations actually. So again, the thing here, the difference between Revit and StatPro is going to be coincidence here again. In StatPro, once you place a load, it has some predefined loading techniques actually in StatPro. But in Revit, until you get the exact knowledge related to a structural person, we can't create an analysis up here. So if you're going to create a load, surface load, now you must define the points here, like what type of force is going to be act, whether it is a live load or a dead load, or what type of load it is. It's going to be a seismic or a static load or dynamic load. Whatever the types, you must feed the data manually for Revit to make your analysis much more better. And once you have applied all kinds of loads up here, like point, area, hosted load, something, whatever the thing you have applied up here, once you have finished these things, apart from this, going to the analyze tab, here you have a structural analysis tab here. So in order to make this result, what we can do is we need a separate software called as Autodesk Robot Structure Analysis. Once you have those packages with you, this model will be exported into Autodesk Robot Structure Analysis to form your analysis report. And robot structure is very, very similar to StatPro. That is the basic difference up here. It is useful for CS students. It's computer science students. See, again, it's a different question actually. The thing here is, if you are able to, if you are a good developer of programs actually, like if you are a computer science engineering student, you are a good developer of programs, you have much more openings in this industry actually, in the design industry. Like for example, as I said to you earlier, as technically that you could develop your own catalogs for your particular product. So in that basis, once the developer is needed for Revit, he could develop programs for those kind of orientations. Like for example, if I want a customized standard for Mina, I can develop my own programs using Python scripts actually. Scripts are available in Revit actually. See here. Yeah, it is called as Dynamo actually. It's called as Revit Dynamo. So once once you go into this, you can develop your own scripts and programs, and you can incorporate into the software to do works much more easier. It is based on a computer language orientations. It is like a developing orientation actually. Okay. And the next thing is, we have around, we saw about steel up here. Next comes the precast concrete. So this is similar to concrete actually. Precast is nothing but it is a predefined one. So we are going to mold the entire concrete into a single element to fix up our model and all. So those kind of design activities will be available in Revit structure. And coming to the analysis again, we are going to apply all kind of loads and all kind of property into this product, and we are going to migrate into robot structure analysis to develop our design techniques. Apart from it, here in this project browser, let me go to some other tools for you. See, section drawings and all, it's able to visible. And once you're creating these kind of drawings, we can export this drawing into multiple formats. Like you can move up into CAD to form detailing work actually. And here you have cross sections, longitudinal sections. So each view you can generate very, very easily in Revit across with correct detailing. So this detailing technique plays a very much vital role in Revit actually. Sorry, so all kind of detailings are helpful in Revit actually. So once you are going to this detailing concept, Revit has its best performance actually. So each and every catalog has been mentioned very, very clearly. You can do detailing works much more better than any other software. Even if it is steel or even if RCC, concrete structures or any kind of plant designs, Revit plays a very much important role coming to this detailing part. Then you can draw similar to your CAD drawings. For example, this is not a just a drawing actually. So you can also draw using, apart from the elements, you can create your own sketches to display in Revit for your product engineering actually. So then comes your schedules. So it is a very, very important thing to create a bill of quantity, like how many columns are there, what is the concrete used for my model, and what are the rebars used. So those kind of schedules also I can do in Revit actually. Here again, you have sheet presentations. So what type of sheet you have? So how we are going to customize your own. This is the default one. So we can also develop our own sheets for our particular model. And see, the basic thing is, once you place sheets, you need not update anything on the sheets. Once you update on the project, it will be updated on the sheets parallelly. Framing plans for your design model, upper house framing. So every sheet, it has independent use you can create for your 3D design model. And also you can link multiple Revit files into your Revit file to work on a collaborative format. The other basic useful thing here is collaboration. So once you come into this collaborate, what we have is we can make multiple people to work on a single model. That is called as collaboration actually. So it can be a structural person. We might have two structural engineers working on the same model, as well as you might have an architect working on a single project. So on that basis, this work sharing plays a very vital role. Nowadays, Autodesk has launched a new product called as BIM 360 Cloud, in which you will be able to upload the entire document through cloud orientation. Like we don't have a physical server, we need not have a physical server to develop our project. It's going to be on a cloud platform. So this is about the structural software that is useful for us. See, actually, software orientations, everything is common actually. Like you have a Stat Pro, you have Tekla, everything is common, but it has some benefits on some part of the detailing. Like for example, Tekla is very well versed in steel designs, whereas Revit is better for RCC and concrete. Even though robot structure analysis does a better job, but people prefer Stat Pro till now because it has been reached the market to that end. So the output what you get is somewhat similar in all the software, that is up to until the data that you given for a structure analysis. So any doubts regarding this? If you want any other queries, you can ask me. So I'll provide you the valid information. Hello.
Yes, Mr. Damodran.
So if students or any other people, you have any queries that regarding this, you can ask me. So it will be better for me to answer you people.
Well, we haven't received any new questions so far.
Okay. So now we have seen about Revit. So I'll navigate to Stat Pro right now. So you'll be having you'll get a somewhat clear idea what is available in that software also. So this tool is again similar to Revit actually, but the thing here is in Revit we can visualize on a 3D basis. Whereas in Stat Pro, once you're going to run up and analyze, you are going to work on a line-based drawing. Like it will be like each and every module will be like will be acting like a member, and here you have all types of default standards which is incorporated into it. For example, let us go to this material tab here. So if you want any kind of materials, so I'll be having a default predefined element in order to run up this analysis. Stainless steel, concrete elements. So whatever the thing I have predefined one, and also I can incorporate some of the standards that is updated up here, like American International Standard Codes of steel standards. So everything is predefinedly available in Stat Pro, whereas those things are not available in Revit. So section drawings can be generated automatically in Revit actually. See, I'll show you a live example here. Let me go to this plan view. Okay, so if I need a section of this one, so I can just create a section like this. So that section will be updated on my project browser. So So like this, you can develop your section drawings for a particular model Revit. So you need not draw a separate drawing. Whereas once you're working with a structural design on AutoCAD basis, you need to draft it again. But in Revit, it's not needed. You can develop your settings automatically. And if you delete any kind of element in this particular view, it will be reflected on the entire model. Okay, that is the advantage of Revit as well. So any kind of model changes will be reflected on all the views. So once you delete in a top view, the entire thing will be deleted for the entire project actually. Any other?
Is there like any roadmap to become a perfect structural engineer?
Roadmap in the sense, any steps he's asking something.
Yeah.
Well, the thing is, you must be stable with your knowledge that you're getting, knowledge that you're gonna got up with you. Apart from it, you need some practical exposure. That what are the physical factors? See, design is just a digital representation actually. So coming to the structural part, if you're going to develop, apart from building, you have multiple structural disciplines like bridges, roadway constructions, subways, and all. So coming to those kind of things, practical knowledge is very essential to cope up with. So coming from the soil test, what you're going to develop, so you need to learn those things on a practical exposure to be a successful structural engineer. Even though you're getting a qualification, a degree or something on a MS of structure or something, apart from it, whatever the knowledge you're getting on practical will help you more to make you sustainable on your career orientation.